So when we simplify or prove, you have to make sure everything's in terms of the same angle. And so on this particular problem, we have two different angles at play. We got theta, and we have 2 theta. So that's the first thing you gotta look for. So you can change everything to 2 theta, you know how to do that, or you can change everything to theta. 90% of the time, you're gonna wanna reduce that angle. So go with the larger angle and get rid of the larger angle. Sometimes, about 10% of the time, you'll want to go the other direction. Okay? And same with your homework, you'll have some, most of them, you're going to be getting rid of the double angle, but some of them you will go the other direction. So for cosine, you have 3 options, right? If you look at your formula sheet, you got cosine squared minus sine squared. You have, what are some of the ones? 2 cosine squared minus 1, and 1 minus 2 sine squared, right? If you're not sure which way to go, by default, use the first one. So cosine squared theta minus sine squared theta over sine theta plus cosine theta. And this will be good review for us for proofs too, or simplifying. So what would you do next? So now we're back to, this is back to lesson 1. Okay, so how do we simplify this? Difference of 2 squares. So factor. So factoring is a technique we can use. So cosine theta minus sine theta times cosine theta plus sine theta all over sine theta plus cosine theta. And now we can reduce that fraction. And our answer is just cosine theta minus sine theta. Can we go any further, or is that as far as we can go? As much as we can do. So it's in term, and I know that because it's in terms of sine and cosine, and there's no squareds, nothing else we can do to that. So again, the key thing is how we start. We had to get the same angle by using that double angle formula. We're going to try another one. Simplify cosine squared x minus 2 cosine 2x plus 1. Jot that down. Do all the angles match? So we have, I'm highlighting the angles here, okay? Those are the angles. Do they match? No. So first step is to get everything into one form. And the easiest way is to change the cosine of 2x. That cosine of 2x, though, is already attached to that negative 2. And so whatever you replace it with, make sure it stays in parentheses, and you're going to distribute that negative 2 to everything that it gets replaced with. So what do we want to replace it with? You got 3 options. Does one option seem more feasible than another if you look at your 3 options? The one with cosine only, and what tells us that maybe we should go that route? Because we already have a cosine. So something's already in terms of cosine, right? So let's replace this with something only in terms of cosine, not with sine. because we're already starting with the cosine. So what goes here? 2 cosine x minus 1 squared. Yes. And then let's simplify as much as we can. And go ahead, I'll give you a 2-minute head start. See if you can simplify it. All right, I'm going to start now. Keep working though. I'm going to distribute. So after you distribute, what did you do? Combine like terms. So the cosine x minus 4 cosine x is going to give me negative 3 cosine squared x plus 3. I'll factor out of 3, not a bad idea. So negative cosine squared x plus 1. Do what? You could factor out a negative, but I don't want to. Because this is equal to sine squared. And that's your answer. You can, because then you'd have a negative 3 and a negative sign, and then that would work. Yep. You could get it another way too. But 3 sine squared is where you want to end up. Okay. Number 3. Simplify. This time I'm going to have you start. Again, I'll give you a 2-minute head start. So the angle's not the same, so we want to use that double angle formula. Tangent of 2x, let's see, should be 2 times the tangent x, is that right? Over 1 minus tangent squared x. And that's times 1 over secant squared x. So here's our tangent 2x. And then I just moved the secant squared x over. What else can we do? So 1 plus tangent squared x is secant squared x. It's true. So is that going to help us? Okay, so you change this, move that up here. Okay, well, that's fine. Did it take you somewhere? Okay. So you put cosine squared x here over 1 minus tangent squared x. Sine over cosine. Okay. So two sine x cosine x over 1 minus tangent squared x. That works. Nothing wrong with that. Anybody get any further or more simplified than that? Well, we can change tangent squared to sine and cosine too, right? So if you're at a standstill, that would be something to do. So 2 sine x cosine x over 1 minus sine squared over cosine squared. And then we're going to change that 1 over 1 to what over what? It does change this. Okay, so we can keep that in the back of our mind. This right here is the sine of 2x if we need it. It does change the angle, but we'll come back to that if that is helpful. Okay, but let's keep pursuing this. Make it one fraction. So that 1's going to change to what? Cosine squared over cosine squared. So I just got a common denominator, right? 1 over 1 is cosine squared over cosine squared. So that can create one fraction. Is this helping? So at least getting in terms of sine and cosine just to see if we can go anywhere else. If we can, this would lead us there. But we have a fraction of a fraction, and we want to simplify that down further. So what do we do? Cosine squared x minus sine squared x, is that -1? Good question. Is it? No. What would be -1? If they were both negative. We can say that cosine squared x minus sine squared x is what? Cosine of 2x. So if we needed that, we could change both of these to a double angle, but then that one's stuck. We'd have to change them all to the same angle. So let's keep working. We don't want to leave it as a fraction of a fraction. So we got 2 sine x cosine x over 1 times cosine squared x over cosine squared x minus sine squared x. So just flip the second fraction over to multiply it with the first. And we got 2 sine x cosine cubed x over cosine squared x minus sine squared x. Any other ideas? All right, then let's call it simplified. I don't see any other way to go. It wasn't a simplified problem. So sometimes you'll have problems that just aren't going down to something nice. That happens. That's simplified. I'd follow your work and see where it led. That's why something like this would probably be better in a proof because you know where you want it to end, right? And but there we go. Next one. This one actually does simplify down to something small. Again, I'm going to give you a head start. Anybody find a good first step? Factor out a cotangent, because we had two terms here. They both have a cotangent squared. Factoring that out is going to be really helpful. And that's what it looks like when you factor it out. What'd you do next? we got to deal with the angle. They have to be the same angle. So we have an x and a 2x, so change that. We have three options when we change out the cosine 2x. Any one particularly helpful? The sine one? Why was that helpful? Okay, so you're thinking ahead with the cotangent. Another thing I would think of is which one's going to cancel the 1 out with the minus 1? Because I have a minus 1 there, and 1 minus sine x, right? 1 minus 2 sine x would cancel with the minus 1. So that's another indicator that you might want to choose that. If you choose the wrong one, that's okay. You can still, they're all equal to each other, so you're not doing anything wrong. It's just maybe adding another step or 2 steps, okay? So if you're not sure what to pick, don't worry, just pick anything. So cosine 2x is the same thing as 1 minus 2 sine squared x minus 1. And we chose that one so that we can do 1 minus 1. And so now I'm going to change cotangent to cosine over sine. They're both squared. And it's times 2, and then it's times sine squared x. So the 2 is, and it should be negative 2. Do that. Yes. And so we could put these over 1 if we want. And so we can reduce this. And we're going to end up with negative 2 cosine squared theta, or x. All right, introduce theta. It should all be x. So that one truly did simplify. Anybody make it there before I did? Our next one is simplify. I'll let you look at it for 30 seconds to see if you can figure out what your first step should be. Okay, you gotta view. So if you look at your angles, we got x and we got x over 2. One of them is double the other. So this is actually the double, because this is x over 2 times 2, right? So you got to view it, although it's x, you got to view it as a double angle. And so you use the double angle formula. Which one would you use? You got 3 options. 1 minus? It doesn't matter. It really doesn't. I'll do 1 minus 2 sine squared x over 2. So we cut the angle in half. Plus 2 sine squared x over 2. And hopefully you see how to finish this one. You get 1. So that one simplified nicely too. Okay, so these are simplifying. I'm going to give you a couple proving ones now. So you're going to make the left side equal the right side. So try 6. Prove that the left side is equal to the right side. So 10 is a double angle. It's 2 times 5x. Okay? And so your first step is to change that to 2 times cosine squared of 5x minus 1. And then add the 1 and the negative 1, and you got your answer. All right, there's your little proof. Okay, next one. Try to prove that 2 times cosecant of 2x is equal to cotangent x plus tangent x. Again, it's not going to be too hard once you get in and try it. Okay, so first step is maybe to change it from cosecant to sine. And when you change it, 2 stays in the numerator, and sine moves down to the denominator. So that would be a good first step. Then there's only one formula for a double angle for sine. It's going to be 2 over 2 sine x cosine x. And you could reduce that fraction. Now you get 1 over sine x cosine x. And then the question is, well, how do we get from that to cotangent plus tangent? Chase sees how. But but for us that get stuck here, what's a good hint? For someone that's stuck here, they're like, okay, I know how to get here, but don't know how to go further. What should they do? Oh. So how did you do it? Okay. So he did sine squared plus cosine squared over, and that's a great idea, right? Now, if you didn't come up with that idea, how could you come up with that idea? So he just changed the 1 to sine squared plus cosine squared, because after that, it's all going to fall into place. So, but if you couldn't come up with that idea, what I would suggest you do is, if you're stuck on the left side, move to the right side. And if I change this to cosine over sine plus sine over cosine, and I'm working with the left side, what would my next step be? Get a common denominator, right? And if I get a common denominator, I get cosine squared, and I get the cosine down here. And I get a sine squared, and I get a sine down here. And now you see that's pointing to the right direction, okay? So if you are not able to just create that, and that's fine, then you go to the right side to get some ideas, okay? And then after this, you guys see how to finish it? Split it into 2 fractions. First fraction is sine squared x over sine x cosine x. And the second fraction is going to be cosine squared x sine x cosine x. And then reduce both of those fractions. And sine over cosine is tangent. And cosine over sine is cotangent. And that is good enough for finishing that one. Okay. Got one last one, grand finale. Got a prize for the first one to get it. Okay. You ready? Last one. Prize for the first one to get it. So most of you saw, okay, we're going to change that 1 to sine squared plus cosine squared. And we're going to change the sine of 2x to, there's only one option, right? So 2 sine x cosine x. And then that 1 is going to become sine squared x plus cosine squared x. Right? And so then the next step is, well, how do you show that this is equal to sine x plus cosine x squared? And the key is, what's the reverse of multiplying? Factoring. Okay, so we need to factor this. Okay? And so when you're factoring, you're looking for two numbers that multiply to what? So there's a 1 here and a 1 here. So multiply to 1 and add to 2. And so it's going to be a 1 and a 1. And so you split up this middle term. So it's going to look like this. Sine squared x plus sine x cosine x plus another sine x cosine x plus cosine squared x. Then you factor by grouping. So over here we factor out a sine x, and we're left with sine x plus cosine x. And on the right-hand side we factor out a cosine x, and we're left with the sine x plus cosine x. Is this looking familiar, factoring? The process that we go through? And then both of these have a common factor, sine x plus cosine x. And what's left is a sine x plus cosine x. And then that is the same thing as squared. This would show the steps. Okay. All right.